Now we move to the section 3, which is the types of crystalline solids. As you can see, there are 4 types of crystalline solids. The first is metallic crystals, then ionic crystals, the third covalent network crystals, and the fourth molecular crystals. From the name implied, you can say that it depends on the types of the atomic bonding of each material. Metallic crystals, the crystal which has metallic bonding. So actually the crystal consists of metal cations, yeah, which is surrounded by the sea of electrons. That's the typical of metallic bonding. Then for the ionic crystals, the crystal structures consist of alternating positively charged cations and negatively charged anions because they have the ionic bonding. Yeah. So this is the typical ionic crystal. So they have different types of uh, cations and anions. Yeah. While in metallic crystal, they are all the same atoms. Yeah. The third is covalent network crystals. It is a crystal that consists of atoms at the lattice points of the crystal, which each atoms being covalently bonded to its nearest neighbor atoms. You know that covalent bonding is a share of electrons. Because of share of electrons, they have a directional bonding. Because of they have directional bonding, the structures of the atoms are in a certain positions. Yeah. So the covalent network crystals, they actually being composed of atoms rather than ions. Because of that, they do not conduct electricity in any stage. And the last is molecular crystals. For this is crystal that formed by molecules, yeah, and each molecules are held together by weak intermolecular force, yeah. Either it is hydrogen bonds, yeah, or van der Waals bonding, yeah. Because they have a weak bonding, yeah, they have a melting and boiling points of this crystal are much lower than the other crystals. Because of that, the properties of crystalline solid, as you can see, metallic crystals, because they have free electrons that bond all the cations, they are good conductors of heat and electricity. Ionic crystals, because it is an ionic bonding, they are poor conductors of heat and electricity at a solid state, but if they are in the liquid state, they may have good heat and electrical conductivity. The covalent bonding, because they are consist of atoms, usually they are poor conductors of heat and electricity. However, they may some exceptions. For example, carbon in the forms of graphite, they have a relatively high electrical conductivity because the electron can move in the carbon planes. Yeah, while for the diamond, it has the highest thermal conductivity. And for the molecular crystal, there are 4 conductors of heat and electricity. And for metallic crystal, their melting points depend strongly on the electron configurations. Yeah, it can be very low, yeah, like in uh, hydrargyrum, but very high in tungsten. Yeah. For ionic crystal, yeah, they have relatively high melting point. Covalent crystal, very high melting points. Yeah. And for molecular crystal, because the atomic bonding is secondary bonding, they have low melting point. Yeah. Metallic crystals, it is easily deformed under stress. Yeah, because the electron ions help to keep the cations bond each other, so they are ductile and malleable. Ionic crystal and covalent crystals, they usually hard and brittle, but the molecular crystal, they are very soft, yeah, because of the soft bonding. The metallic crystal, usually they have high density because they are highly packed, yeah. Ionic crystal relatively dense, yeah, but a bit lower because different size of ions and cations. Covalent crystal, because they have directional bonding. They have to the direction must be at a certain the bonding must be at a certain direction. They have low density, and of molecular crystal also have low density. Metallic crystal, they have lustrous surface. The ionic, covalent, and molecular crystal, they have dull surface. And this is the examples of the melting point and normal boiling points, as has mentioned before. Metallic crystal, it can the hydragium, they have a very low melting temperatures, minus 39. Sodium, aluminium 660, gold 1064, tungsten 3040. 3410 degrees Celsius. Yeah, so very a lot. Ionic crystals, natrium chloride 800, calcium fluoride 1400. Yeah, covalent crystals, they usually very high. Boron, because of the covalent bonding, 2067, diamond 3500, silicon oxide 1600, and molecular crystals, they have low melting point. As you can see, this is hydrogen and H3, H2O or ice 0, yeah, and the normal boiling point is proportional to the melting point. Now we